right, so today's video is how electricity flows in a wire. So we're going to be talking about copper. Copper is one thing we'll talk about here. Let's get the pen going. Let's use blue, why not? So copper is the second most conductive metal. It's the second most conductive. Write that down there. It's not the most conductive. What do you think is the most conductive? Silver, right. Silver is the most, but it is also more expensive than copper, so it's not practical to use. So we have silver, copper, then there's gold, which is even more expensive than silver, much more expensive. And why don't we just throw in a fourth one? Aluminium or aluminum, as we say in America. So we have silver, copper, gold, and aluminium. I'm going to say aluminium. They are in order from the most conductive to the least in the as far as these four go. So we're going to see how electricity flows, and we'll talk about some of the properties of it. Okay, so first of all, what is electricity? So we're talking about, again, electricity in a wire. So we have a charged carriers. Charged carriers. Okay, it's a little messy there. Charged carriers. Fix that a little bit. Right, and the type of charge carriers there are, right? So let's put a line there. So we have electrons, which we're talking about today. Electrons, and they're negative, right? They have a negative charge. All right, and then we also have ions, which we'll talk about in a minute. And we also have holes, which we'll talk about in another video. Actually, ions and holes we'll talk about a little more in other videos, but I'll talk about ions in a minute because it's important in this video. So again, these are the charge carriers that move within the wire. So it creates that electric flow. Electric flow. Okay, so we are looking at the electrons. And in order to know about how those electrons move, let's look at the battery. So here is the negative side of the battery right here. This is where the electrons will move from. They're moving in this direction. Very important to know. Electrons will move in this direction. And they may come across this switch here. Right now, this is a closed circuit. Electrons will move in a closed circuit. They won't move if the circuit's opened. I think that's common sense right there. All right, so let's put closed circuit right there. So if the circuit is closed, the electrons will flow this way. They'll flow into this lamp, which is a resistor. We'll talk about that in other videos. The resistors are measured in ohms. That's the symbol for ohms, the Greek omega sign. So basically at the resistor, they're just slowing down, causing heat. And of course, they'll flow back to the positive side of the terminal. We'll talk about really how batteries work, how they're made in another video. So let's concentrate more on how this flow is happening. Okay, so the first thing we want to talk about, basically, when we look at the diagram of, let's just get our, okay, so here is a copper atom, so it's important if we look at that first. So you notice there is these clouds, some people call them rings, clouds, rings, orbits, orbitals, or energy levels. They're really clouds and energy levels. So I'm just going to say energy levels. So you can notice copper has 4 energy levels right here. And at the last energy level right there, there's only 1 electron. So the electrons in the last shell, it's another word people can say, the last shell, or the last energy level, are called valence electrons. So again, it depends on how many, it doesn't depend on how many there are. There could be many of them. So copper has 1 valence electron. Okay, so we had copper had one valence electron, but notice this is aluminum, aluminium. Right, you have two here, one there, so they have three. Aluminum has three valence electrons. Now, the valence electrons don't determine how good of a conductor it is. That is free electrons, and to be simplified. So I'm talking about free electrons now. Okay, so we went over what valence electrons are, but free electrons are exactly that. They're free. They're free inside the wire. So let's make this cross section here. Let's use purple. Why not? So let's just say this is a copper wire, right? And you notice in a copper wire when there is a metallic bond going on, there's metallic bonding going on. Metallic bonding. And in metallic bonding, you have this crystal structure forming inside the wire. And you notice there is ions. There's positive ions. That's what the plus symbol is. And these free electrons. So look at all these free electrons. There's a lot of free electrons in copper. So basically, and we'll talk about ions in a minute. So if this is the battery, right, the electrons from the battery are coming into the wire and they're causing this electrical field, causing a field, electrical field. And all the other electrons, these free electrons, don't want to be anywhere near this electron, right? So it's causing this repulsion, right? It's a repulsive force, right? Opposites attract, but the same charge, they don't want to be near each other, right? So this electron is causing this flow, right? So all these electrons, these free electrons, again, these are free electrons, they're free to go, are moving inside the metal in the copper wire. And you can see it here again. But the electron itself, these electrons themselves are not moving, each one is not moving the speed of light. They're not moving very quickly. In fact, they're moving at 1 millimeter per second, which is very slow. We can move faster than that. But the overall field is moving very quickly, right? So let's go back to the diagram with the battery. Show this. So again, we have the flow is going this way. Remember the flow, the electrons are moving from the negative terminal into our resistor. There's another switch. This is, by the way, a simple circuit. Simple circuit. And again, it's these free electrons, important word, the free electrons that are moving, and again, they're only moving 1 millimeter per second, but they're causing this chain reaction. They're causing an electric field to instantaneously, at the speed of light, close to the speed of light, turn that light bulb on. Very quickly does it happen. But if you opened up a battery and if somehow you can see an electron, which we can't, you would see it's going only 1 millimeter per second. Again, so if we had, let's say, pretend there's an electron, even though they're not really circular, they're not really orbs. If this was an electron and that was an electron, right? They both have a negative charge, so they don't want to be anywhere near each other. They're going to repulse each other. They're going to repulse away, right? So if this electron comes in, this electron's going to go out, and then another electron over there is going to go out. So it's kind of like if we line up people in line, let's say the Rockettes, and these are not a good drawing of Rockettes and by any means, but if you ever see the Christmas show during the finale, right, there is this pretend cannonball, pretend that's an electron, and it hits the rocket, and there's a domino effect where they keep moving down the line, and it happens very quickly. So that's what basically is happening, very simplified, is when the electron enters the battery, there is this kind of a domino effect where each electron is repulsed almost instantaneously as they move through the circuit. Okay. All right, so let's go back to make sure we understand this. Let's get the pen working first. Let's go to green. So let's make sure we understand this. This is the copper wire, and here is a battery. Let's say copper wire is attached, remember, to the negative side, not the positive side. So let's just say, electron again. This electron comes in through, and all the free electrons in the copper are going to be repulsed. Like they want to get away. And that's what happens is as these electrons move in for the battery, all the free electrons are moving also. So this free electron is going to move here, and it's going to cause this one to move away and so forth like that. And again, this is oversimplified because obviously the electron is not uh, in any way trying to be attached to that electron. It's just that this electron is causing it to move, and then the field itself that's generated is causing the other ones to move. So it's that field that's kind of generating, that's pushing everything away. Now, I'd said we have to talk about ions very briefly. Okay, so this is a regular copper wire, copper atom. And you notice again, just to review, we have as one valence electron. Remember, what is a valence electron again? The last shell, the last orbital. How many whatever's on the last orbital, those are valence electrons. And remember, aluminum had 3, or aluminium, but copper has 1. Now, there's no charge in this, but when copper atoms get together in metallic bonding, this valence electron kind of leaves and it becomes free. So there's a free electron. Once it becomes free, then it's an ion. So an ion can either be positive or it could be negative. So a positive ion means it has more protons because protons are positive. It's more protons. Be a positive ion. And if it had more electrons, let's say, for example, that stayed and somehow another electron joined, then it'll have more electrons. More electrons would be a negative ion. Right? And there's other videos on ions. So that's briefly what ions are. So if we go back again, what's happening in our diagram, okay? So now, as you can see, all these copper ions are now positive ions. They're positive because they lost an electron, and the electron that they lost is these free electrons, and they're all over in metallic bonding. So all we need is for a chemical energy from the battery to come in, and it comes in as get the pen going here. Let's use this color, whatever, that magenta, something like that. Who knows? So this electron comes in. Negative electrons are coming in from the battery, and they kind of disturb this. They kind of create an electric field, and it starts moving. They start moving, and that's very simplified what's going on. So let's sum this up now. We talked about the types of conductors there are. We know that silver is the best. We talked about then copper is second, and we're using copper today because it's more affordable. Then gold, and then of course we said aluminum or aluminium. So those are the conductors, and we know that in metallic bonding there are a lot of free electrons within the wire, and it causes these ions, which are also charged, and they're positive ions in the metal, as you can see here. And all it takes is this electron, or we say electrons coming in from the battery. Let's make the battery here. Actually comes in from the negative side. Remember that the electrons come from the negative side before returning to the positive side. And just one more time with our simple electric circuit, which way do the electrons flow? Right, they're flowing from the negative side of the battery. They're flowing this way. And again, they do not flow. One electron does not move at the speed of light or close to the speed of light. Right? It's not doing that. Remember, it's flowing about 1 millimeter per second, which is slower than us. We can move faster than that. But Actual light is 186,000 miles per second, which we can't even get nowhere near that, and we never will, right? So the field is moving close to the speed of light. The field that it's generating is close to the speed of light, but each individual electron is not doing that. So now in the next video, we're going to talk about more about electricity outside of copper wires too. All right, let's put a little emoji. I think we did a good job here. What kind of emoji? We'll put the thumbs up. Right, a little thumb up there, and why not put a little celebration. Good job. All right.